I am Miza Observer from the Department of Chemistry, Batch 5. My topic is about smart sensors and IoT in fertilizer applications, carbon neutral fertilizers, and carbon sequestration. This assignment is being submitted to Dr. Hamad Majid. Now, let's talk about the table of content, which includes introduction, smart sensors, how do they work, different types of smart sensors, what are they used for, their advantages and disadvantages, and then we'll talk about IoT based smart fertilizer management system. IoT stands for Internet of Things, its existing method and hardware components. Then we will discuss carbon neutral fertilizers, nitrogen producers facing change, carbon sequestration, its types, which are biological and geological, and then the impacts of carbon sequestration. Then we'll study about smart nutrient delivery system, nanofertilizers, class of nanofertilizers, and then sustainable fertilizer development, the needs for sustainable fertilizers, different pathways, and future perspective, and then the conclusion. Now, let's talk about the introduction of smart sensors and all those other fields. Smart sensors and IoT in fertilizer application have revolutionized the field of agriculture, particularly in the application of fertilizers. These technologies have enabled real-time monitoring and precise control of fertilizer application, optimizing nutrient levels and reducing waste. The Nobel Prize hasn't been awarded in this field, but the scientists are still working, and it is estimated that these advancements in these areas may occur after the last update, which was January 22. No Nobel Prize has been given, but scientists are still working on these topics. Now, let's talk about smart sensors. A smart sensor is a device that takes input from the physical environment and uses built-in compute resources to perform predefined functions upon detection of specific input and then processes data before passing it on. What does it mean? It means that smart sensors are devices that gather information from the physical environment, utilize internal computing power to execute predetermined actions upon specific inputs, and process data before transmitting it. They ensure more precise and automated collection of environmental data by reducing inaccuracies within the recorded information. Employed in various settings like smart grids, battlefield, scientific explorations, and integral to the Internet of Things, which is IoT. These sensors enable unique identification and data transmission of items through the Internet or similar network. They often operate as component within wireless sensors and actuator networks comprising multiple interconnected nodes, each containing sensors and microprocessors and wireless communication technology. Crucially, smart sensors necessitate their compute resources to be an intrinsic part of their physical design and encompass various components beyond the primary sensor, including transducers, amplifiers, digital processors, and communication interfaces for seamless interaction with external devices. Now, what are smart sensors used for? Smart sensors have many uses. They are commonly found in industrial environments and are the driving force behind Industry 4.0, industrial automation, robotics, and other instrumentations. Factories often use smart sensors for diagnostic purposes. Smart temperature sensors ensure machines aren't overheating, and vibration sensors monitor machines at risk of vibrating loose. Smart sensors also enable process control, such as monitoring a manufacturing process and making necessary adjustments so that it can meet quality or production goals. These were once manual processes, but smart sensors have automated them. Smart sensors also play a key role in the advancement of modern security. Thermal imaging sensors detect an intruder's body heat. Similarly, devices such as smart locks, motion sensors, and window and door sensors are commonly connected to a network. This lets the security sensors work together to create a comprehensive picture of the current security status. In this picture, you can see that how an IoT sensor is in action. There is a cloud which shows the climate change, and then it is detected by the IoT that is in the access point or hub. And then the information further passes to sensors which are thermal, sound, location, etc., the microprocessors, communication capabilities, and then it could also include transducers, transceivers, and sources, and more. Now, how do smart sensors work? Smart sensors connect a raw-based sensor to integrated computing resources that enable the sensor's input to be processed. Smart sensors operate by integrating various components to gather, process, and transmit data. They comprise a sensor to collect information from the environment and microprocessor for computation and wireless technology. When the sensor detects specific input, the microprocessor executes predefined function processing the data before transmitting it. These sensors often involve additional components such as transducers, amplifiers, and digital processors for accurate measurement and data correction. Smart sensor technology also contains integrated communication capabilities that let them connect to a private cloud computing environment or the internet. This lets them communicate with external devices. What are the different types of smart sensors? There are different types of smart sensors, but the five which I am going to discuss with you, these are used commonly in industrial IoT environments. These are level sensors, temperature sensors, pressure sensors, infrared sensors, and proximity sensors. Let's talk about the level sensors. These are used to measure the volume of space taken up in a container. That means that a vehicle fuel gauge might be connected to a level sensor that monitors the level of fuel in the tank. Now let's talk about the temperature sensor, as its name tells that it detects the temperature, so a corrective action can be taken if the temperature gets too high or too low. For example, in an industrial setting, a temperature sensor is used to ensure machinery does not overheat. Pressure sensor is used to monitor the pressure of gases or fluids in the pipeline. A sudden drop in pressure might indicate a leak or a flow control system issue. Infrared sensors are optical sensors tuned to a frequency that helps them see light in the infrared spectrum. What are proximity sensors? They are used to detect the location of a person or object in relation to the sensor. In retail environment, proximity sensors can track customer movement throughout the store. Now, let's talk about the advantages and disadvantages of smart sensors. Smart sensors come with a range of benefits, but they also have challenges and drawbacks. Let's talk about the advantages. It includes precision and accuracy, automation, efficiency, integration with IoT, adaptability. If we talk about the precision and accuracy, then the advantage of smart sensors are most prominent when they are used for data collection or remote locations. If we talk about the efficiency and sustainability, with their ability to process data locally, smart sensors reduce the load on central systems, improving overall efficiency. Integration with IoT, they play a crucial role in the Internet of Things, allowing seamless connectivity and data sharing between devices and systems. High performance. Smart sensors can collect data with consistency and speed with real-time data is needed. Now let's talk about the disadvantages. Smart sensors developers have consistently upgraded their offerings to address long-standing drawbacks and will continue to do so in the future. That said, it may be a while before the current disadvantages of these devices are addressed. This could be the cost. Implementations and maintenance of smart sensors can be expensive, especially when integrating them into existing systems or infrastructure. Complexity. The complexity of the technology might require specialized knowledge for installations, operations, and maintenance. Expertise. Smart sensor system might require levels of IT expertise not all organizations have. New hires or training could be needed. Meeting requirements for IoT deployments. Whether in a smart home or in an industrial setting, other factors must be taken into consideration before deploying IoT devices, like the power consumption required, the need for stable online connectivity, and the ability to handle higher volumes of data. Now, let's talk about the smart fertilizers management system based on IoT. In Asia, the agriculture plays a pivotal role in enhancing food production. Automating conventional farming practices is crucial for improved productivity. The excessive use of water resources has led to a significant decline in water ground levels due to insufficient rainfall and scarcity of land water, resulting in reduced water volumes on Earth. Water is indispensable in various fields, especially in agriculture where it is required in substantial quantities. Water wastage poses a significant change in agriculture. Numerous methods aim to conserve and regulate water usage in farming, similar to maintain management and effective fertilizer management is integral to crop protection. The proposed system involves storing various types of fertilizers in separate tanks positioned above a large water connected to drip irrigation pipes through electric valves in the field. Soil moisture sensors installed in the field transmit SMS notification to the farmer's mobile device via a GSM module. Farmer inputs specific alphanumeric values relayed to the controller through the GSM module, which then triggers the electrical valves to determine the duration of valve opening. This process allows the fertilizers to mix with water in the tank before being dripped into the fields using the drip irrigation method. Now, let's talk about the existing method. In the sensor-based machinized water system frame with IoT, the utilization of sensor-based irrigation occurs in response to changes in the temperature and humidity in the surrounding. The water flow is regulated based on the electrical valve. The microcontroller governs the opening and closing of the valve in response to received signals. Plant watering is conducted drop by drop using a sprinkler when the moisture level returns to normal as sensed by the sensor, transmitting a signal to the microcontroller to close the valve. Two mobile devices are connected via GSM, while GSM and the microcontroller are linked through MAX 232. The microcontroller transmits a signal to the mobile device, activating the alarm. The alarm indicates the valve should be open, and upon receiving the request, it signals the microcontroller, which then communicates with the valve. Now, let's talk about the hardware components: Arduino microcontroller, soil moisture sensor, and the GSM module. These are used as a hardware components, and the conclusion tells us that the IoT-based water system framework with Manure, the board framework, was discovered to be savvy for improving the compost and water assessed for crop creation. This proposed method can be used to on-off the fertilizer tank and drip irrigation system remotely depending on soil moisture levels. This framework decreases the water and compost utilization to a bigger degree. The forest utilization and the keep-up have been diminished without question. The yield efficiency increments and the waste of assets are decreased without a question. Now, what is carbon neutral fertilizer? Carbon neutral fertilizer refers to fertilizers produced and utilized in a manner that does not contribute to an increase in the net amount of carbon dioxide in the atmosphere. These fertilizers are typically manufactured using processes that either capture and store the same amount of carbon dioxide emitted during their production or employ methods that offset the carbon emissions in such ways, such as using renewable energy sources or implementing carbon sequestration techniques. The goal is to minimize the carbon footprint associated with fertilizer production and application, thereby reducing the impact on climate change. Intensive agriculture is possible only if the soil is fertilized with nitrogen, phosphorus, and potassium. While phosphorus and potassium can be mined as salts, for nitrogen fertilizer has to be produced laboriously from nitrogen in the air and from hydrogen. Now, if we talk about the countries that are at risk, that are India and China. The following countries are particularly vulnerable to price shocks in the natural gas and nitrogen markets, which includes India, China, Brazil, France, Turkey, and Germany. Now, let's talk about the carbon sequestration. Carbon sequestration is the process of storing carbon in a carbon pool. Carbon sequestration is a naturally occurring process, but it can also be enhanced or achieved with technology. For example, within carbon capture and storage project. There are two main types of carbon sequestration: geologic and biologic. Biological carbon sequestration. In it, the storage of carbon dioxide is vegetation such as grassland or forest, as well as in soil and oceans. Oceans. Oceans absorb roughly 25% of carbon dioxide emitted from human activities annually. Carbon goes in both directions in the ocean. When carbon dioxide releases into the atmosphere from the ocean, it creates a positive atmospheric flux. A negative flux refers to the ocean absorbing carbon dioxide. Think of these fluxes as an inhale and as exhale, where the net effect of these opposing directions determines the overall effect. Now, by 2100, much of the global ocean is expected to be a large sink of carbon dioxide, potentially altering the ocean chemistry and lowering the pH of the water, making it more acidic. Now, let's talk about soil. Carbon is sequestered in soil by plants through photosynthesis and can be stored as essential soil organic carbon. Agroecosystems can degrade and deplete the SOC level, but this carbon deficit opens up the opportunity to store carbon through new land management and practices. Soil can also store carbon as carbonates. Such carbonates are created over thousands of years when carbon dioxide dissolves in water and percolates the soil, combining with calcium and magnesium minerals, forming caliche in desert and arid soil. Forest. About 25% of global carbon emissions are captured by plant rich landscapes such as forest, landgrass, and rangelands. When leaves and branches fall off plants or when plants die, the carbon stored either releases into the atmosphere or is transferred into the soil. Wildfires and human activities like deforestation can contribute to the diminishment of forest as a carbon sink. And grassland can also contribute in the biological carbon sequestration. Now, let's talk about the geological carbon sequestration. Geological carbon sequestration is the process of storing carbon dioxide in underground geologic formations or rocks. Typically, carbon dioxide is captured from an industrial source such as steel or cement production or an energy related source, such as a power plant and natural gas processing facility, and injected into porous rocks for long term storage. Carbon capture and storage can allow the use of fossil fuels until another energy source is introduced on a large scale and for a longer period of time. But let's talk about now the impact of carbon sequestration. About 25% of our carbon emissions have historically been captured by Earth's forests, farms, and grasslands. Scientists and land managers are working to keep landscape vegetated and soil hydrated for plants to grow and sequester carbon. Now, what is a smart nutrient delivery system? A smart nutrient delivery system is a technology advanced approach to providing essential nutrients to soil, to plants. It involves a system that intelligently and precisely administers specific nutrients to plants based on their needs, often using various sensors, data analysis, and automation. These systems monitor environmental conditions, plant health, and soil quality to determine the exact nutrient required, then can be dispense the necessary nutrients in optimal amount and at appropriate times, often through automated mechanisms like drip irrigation, hydroponic systems, or precision agriculture methods. Smart sensors and smart nutrients delivery system aim to enhance plant growth, minimize wastage of resources, and improve overall crop yield by providing tailored and precise nutrition to plants. Let's talk about the nanofertilizers. Smart nutrient delivery system nanofertilizers are also termed as smart fertilizers. Nanofertilizers are synthesized or modified form of traditional fertilizers. Bulk material are extracted from different vegetative or reproductive part of the plants with different physical, chemical, mechanical, or biological methods along with the help of nanotechnology used to improve soil fertility, productivity, and quality of agricultural produce. What are nanoparticles? These are nanopowder or nanocluster or nanocrystals in a small particle with at least one dimension less than 100 nanometer, where 1 nanometer is equal to 10 to 9 meter, 1 billionth of a meter. As a result, there is no silicic acid, iron, and calcium for fixation of the phosphorus, increase phosphorus availability to the crop plant. The classes of nanofertilizers could be nanoscale fertilizers, which contain nanoparticles which contain nutrients. Nanoscale additives, traditional fertilizers with nanoscale additives, nanoscale coating, traditional fertilizers coated or loaded with nanoscale. Now, nanomaterial coating such as nanomembrane may slow the release of nutrients, or a porous nanofertilizer may include a network of channels that retain the nutrient solubility. What is a smart nutrient delivery system? SNDS. SNDS should consider the factors such as time control specifically or control targeted, remotely regulated, and pre-programmed and multifunction characteristics to avoid biological barriers for successful targeted release of required nutrients. Nanofertilizers have high surface area, sorption capacity, and control release kinetics to target sites, attributing them as smart delivery systems. Now, let's talk about the sustainable fertilizer development. The rapid growth in the global population has substantially increased the demand for agricultural produce. To meet the agriculture demand, fertilizers are overtly used in agricultural lands. Typically, the formulation of chemical fertilizers is associated with high energy requirements, non renewable resources, and greater carbon dioxide emissions. Therefore, scientists have been working on developing sustainable fertilizers. Why is it the need for sustainable fertilizers? A sustainable agriculture system ensures optimal water, energy, and nutrition usage and decreases environmental impacts. It also encourages a reduction in the dependence on depleting natural resources and maintains global economic strength. Plants require both macronutrient and micronutrient for their growth. Since most agricultural soils are nutrient deficient, farmers use additional fertilizers to increase crop growth. Macronutrients such as nitrogen, phosphorus, potassium are required in larger amounts, but micronutrients such as calcium, boron, copper, manganese, zinc, and molybdenum are required in relatively smaller amounts. Now, let's talk about the different pathways for sustainable fertilizers. The US Environmental Protection Agency described sustainability as the ability to create and maintain the conditions under which humans and nature can exist in productive harmony to support present and future generations. It includes recovery, reduction, cycling, and reuse. Recovery and reuse are involved with processes that directly generate useful waste products, for example, sewage treatment, and reuse them as fertilizer. Recycling is associated with converting waste to useful products, while reduction involves the decreasing of natural resources, energy requirements, and the cost of fertilizer production. The manufacture of nitrogen fertilizers can be made more sustainable by using alternative methods. Another form of sustainable fertilizer is bioformulation fertilizer. This type of fertilizer contains encapsulated microorganisms that benefit plants, nutrient fixation, and mobilization. Now, let's talk about the future perspective of sustainable fertilizer development. In the future, alternative greener methods will be required for fertilizer development using nano based energy efficient fertilizer production and recovery methods promote sustainable fertilizer management. Microbes and chemical additives are currently used in fertilizer formulations to improve nutrient use efficiency. Now, let's talk about the conclusion. The range of smart sensors application in different areas is broad. Smart sensors technology have been used for monitoring and control mechanisms in a wide variety of environments, including smart grids, flood, and water level monitoring systems. Environmental monitoring, traffic monitoring and control, energy saving in artificial lighting, remote system monitoring and equipment fault diagnostics, transport and logistics, industrial applications, and animal tracking, telecommunications, micro electromechanical systems, and process control, the military, and more. In the future, the alternative greener method will be required for fertilizer